Hello students, welcome to Saurabh's classes. Today we'll be solving the ISI Msqms question paper of year 2017. Today we'll be solving question number 19 and question number 20 on the paper. So let's begin with question number 19. In question number 19 it has been said that there are two particles which are moving with uniform velocities u and v respectively along x and y axis, and each are directed towards the origin. If the particles are at distances a and b from the origin respectively, then the time at which they are nearest to each other will be equal to. The options are au upon u square plus v square. Option B is bu upon u square plus v square. Option C is au plus bv upon u square plus v square. And option D is au upon bv. These are the options. So to solve this, we'll use a graphical method over here. What we'll do, first we'll draw the y-axis, and this is the x-axis. This is x and this is y. Suppose the first particle is at a distance a, and it is moving with the velocity u towards the origin. And suppose the second particle be at y, at this position where y is equal to b, and this moves with velocity u, with velocity v, small v. Let us assume that after at time t, the particle which was initially at a reaches a1, and the particle which was initially at point b reaches point b1 at time t. At time t. So we have to find out the time at which the distance between the particles at a1 and b1 are the minimum. So what we'll do over here, the distance which is traveled from a1 to from a to a1 is given by s of x, and s of x is nothing but equal to ut. This s of x is nothing but equal to a minus a1. This is equal to ut. So you can safely write that a1 is equal to a minus ut. Similarly, s of y is equal to vt. Now s of y is equal to b minus b of 1, that is equal to vt. This implies that b1 is equal to b minus vt. So the distance between these points, which will be given by d, so d square we can write as a1 square plus b1 square. So d is basically this portion. This is given by a1 square plus b1 square. This is equal to a minus ut whole square plus b minus vt whole square. Now let me use the space below so that I can solve this problem. So I'll take this up, and then let's proceed with the sum. Now what we'll do, we'll try to differentiate this. So upon differentiating, this will give us 2d into d of d upon dt. This is equal to 2 into a minus ut into minus of u plus b minus vt upon minus of v. This is equal to 2 of minus of au plus bv plus u square plus v square into t. This is equal to 2d into dd dt. Upon cancellation, dd by dt will be equal to 1 by d u square plus v square into t minus au plus bv. Now for minimum dd by dt is equal to 0. We always know that distance will be always positive in any case, so that implies that u square plus v square into t minus au plus bv is equal to 0. This implies that t is equal to au plus bv by u square plus v square, and this is the option C. Now let's move on to the next question. In the next question, which is question number 20, it has been said that let the function f of x be defined by x square plus x minus plus sin x minus cos x plus log of 1 plus mod of x. This is the definition of f of x, and it is defined in the interval -1 to 1. Then the function gx, which is also defined on the interval -1 to 1, and satisfies g of minus of x is equal to minus of f of x, is given by, these are the options which are supposedly equal to g of x. So we need to find out g of x. So now we have been given that f of x is equal to x square plus x plus sin of x minus cos of x plus log of 1 plus mod of x, where x lies between -1 to 1. This implies that minus of f of x will be given by minus x square minus x minus of sin x minus cos x plus of cos x minus log of 1 plus mod of x, where x lies between -1 and 1. This implies, now we know that minus of f of x is nothing but is equal to g of minus x. So g of minus x will be equal to minus of x square minus of x minus sin x plus cos of x minus log of 1 plus mod of x, where x lies between -1 to 1. Now if we replace, put minus x over here, then also the value of minus x will lie between -1 and 1. So this will be equal to minus of x square, minus of x we can write as plus minus x, sin of minus x we can write as plus of sin of minus x, and cos of x and cos of x minus x is equal minus log of 1 plus, if x lies between -1 and 1 and minus x also lies between -1 and 1, in that case mod of x will always lie between 0 to 1. We know that. So basically if we now replace minus of x by x, then g of x will be given by minus of x square plus x plus sin of x plus cos of x minus log of 1 plus mod x, where x will lie between -1 and 1, and this is the option B. So the option B is the correct option. So we have solved today question number 19 and 20 from the ISI Msqms question paper of year 2017. We'll be solving the next questions in the subsequent videos. Till then, keep watching Sources Classes videos for more solutions and content. Thank you very much.